Hello and welcome back to Math Class in Session. Great to be back. The cosine law. Progressing from the sine law done recently, now it's time for the cosine law. Given any triangle, and it means any triangle, it doesn't have to be a right angle triangle. That's the point. Given any triangle, say ABC, we have the cos law. It's a statement we can make about a relationship between the sides and the angle. For example, here, we could say a squared equals b squared plus c squared minus 2 times b times c cosine of a. It's kind of like a journey across the triangle that you have to get used to. I start here, I say blah, 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 and I end up going cosine a. A squared equals b squared plus c squared minus 2 times b times c cosine a. It's just a pattern that you must get used to. I could start at b and say b squared equals a squared plus c squared minus 2 times a times c cosine b. B squared equals a squared plus c squared minus 2 times a times c cosine b, like that. I could start at c and say it to yourself. C squared equals a squared plus b squared minus 2 times a times b cosine c. Like that. It's just a journey across the triangle that starts at a side. It ends by saying cosine of that opposite angle. Notice how it starts like Pythagoras. A squared equals b squared plus c squared would be Pythagoras if I stopped there. But it's not a right angle triangle, so I can't stop there. Minus 2 times b times c, whatever those are, times the cosine of whatever this was. Notice it doesn't matter what the letters are. It could be P, Q, R. It could be X, Y, Z. Now, this is when you want to find a side. If I wanted to find side B, I'd say b squared equals a squared plus c squared minus 2 times a times c cosine b. Suppose I wanted to find an angle. We could plug into this and then start doing math and rearranging, or we could just memorize another pattern. Now, memorizing patterns is fun and easy, and it's your business. Certainly, if you're headed for university, it's something that you need to get used to. So let's learn another pattern starting at an angle. So consider, if I copied this statement, a squared equals b squared plus c squared minus 2bc cos a, grabbed a hold of this term and dragged it across the equal sign, and simultaneously took a squared and pulled it over and made it minus a squared, it would then look like this. Check it, drag that across, a squared becomes minus a squared, and then divide through by 2bc, both sides divided by 2bc. We get cos a equals b squared plus c squared minus a squared over 2 times b times c. Notice how this is a b here and this is a c, like these two. See these two positive ones? Those are the factors on the bottom as well. So cos a equals b squared plus c squared minus a squared over 2 times b times c. A little pattern. Cos a equals b squared plus c squared minus a squared over 2 times b times c. It's a pattern, so let's try b. Cos b equals a squared plus c squared minus b squared over 2 times a times c. It's a pattern to get used to. And cos c equals a squared plus b squared minus c squared over 2 times a times b. Just dwell on this a little bit, because the thing is, the cosine law is critical. It's used in every lesson, every question, it seems, in grade 12 calculus where it gets to the vector section. It's constantly, and this is a cos law question. So the sine law and the cos law are fundamental to your studies in math. Let's do some examples. Oh, before we do examples, let's say, when do we use this? When would you use a cosine law? When would you use a sine law? Well, we use a cos law when what we know about a triangle is a side and an angle in between those sides. It's called an SAS. S stands for side, A stands for angle. When the angle is in between the two S's, like this, we use a cos law. Or when we don't know any angles at all, but we do know all three sides. This is called SSS for side, side, side. This is when you use a cos law. Notice that for any triangle, we just need to know three things, and we can say everything about that triangle. A right angle triangle, you have to know one, that it's a right angle. Two, you have to know a side and an angle, or two sides, and then use Pythagoras. So you need to know three things about a triangle. If these are the three things you know, this is when you use a cos law, or a cosine law. In summary, triangle trigonometry summary. If it's a right angle triangle you're working with, you don't need a sine law, you don't need a cos law, just use SOHCAHTOA, basic grade 10 trig for right angle triangles. Oh, sure, you can use these complicated laws, but why? It's not necessary. If you know SSS or SAS, if you know this, or three sides and no angles, this is a cos law. The sine law will not work, by the way. And for everything else, when you know three things about a triangle, and it's not a right angle triangle, and it's not one of those two, then it must be a sine law usage. This is when you use which law? Let's do some examples. Find side P. We'll use the pattern. P squared equals 25 squared plus 34 squared minus 2 times 25 times 34 times the cosine of 116. Notice it's P squared here. So then we have to do this math. I squared everything and multiplied this out. Now, please don't say it's 1156 plus 625 minus 1700 and then figure that out and multiply by cos 116. That would be wrong, because the 1700 is multiplied by the cos 116. Do this on a calculator, and do it for yourself, by the way. Don't take my word for it. And then take the square root of both sides, and we found what P is. It says find side P. This is using the cos law, because after all, we did know SAS. Find the angles if we know SSS. Okay, to do this, make sure that you choose to find the biggest angle first. There's a reason for that. Trust me. You want to find the biggest angle first. And the biggest angle is always opposite the biggest side. So for finding the angles, you find the biggest one first. And so we'll look for the biggest side, which is 42, and make sure, and so we'll go after side or angle C, because that's going to be the largest angle. So we'll start by saying cosine C equals 21 squared plus 26 squared minus 42 squared. It's that other pattern. Cosine C is 26 squared plus 21 squared minus 42 squared, all divided by 2 times 21 times 26. Calculator it, and we'll notice that the cosine is negative. Cast rule is telling us it must be in the second quadrant. It must be bigger than 90 degrees. Inverse, now look at this. See the COS? It steps across the equal sign and becomes inverse COS. As simple as that. Inverse this on your calculator, and you have a second quadrant angle, 126.3 degrees. Now, once you've used the cos law, you don't have to use it a second time. Now we'll use a sine law. Sine B over 21 equals sine of that angle we just figured out over 42. I multiplied the 21 over, turned it into a decimal. Now the SIN steps across that equal sign and becomes inverse SIN. and the calculator tells me angle B. So we used a cos law, then we used a sine law, and you never have to use either one of them twice. The third angle falls like dominoes. It's 180 degrees with these 2 bites taken out. So angle C must be 180 degrees, take out the 23.8, and then take out the 126.3. And so we have all the angles. And that's a cosine law, folks.